My name is Victor Odigoma Oya, and once again we are still in circle theorems. In the last class, we were able to show that the angle which a chord subtends at the center of the circle is equal to the angle is twice the angle which is subtends at any other point, the circumference of the circle. And we're able to do that proof and clearly show it. So please check out on that class. Now we are looking at the second one that says angles in the same segments are equal. It's very brief. It doesn't take more than a few minutes to show that. Remember, when we are done with these theorems, we will now see how we can be able to apply them in solving problems. That's the reason why you have to stay with us. Okay. So as quickly as possible, I would say the circle A B C D has its center O, comma, and then we want to required to show that what we want to show here is that this angle ABD is equal to ACD. We want to show that these two angles are equal. Just in few lines, in few steps. Okay. Now, here we go. We will start by saying construction. Join. I have done it already. Just to be able to, you just join AO and DO. Join AO, which is equals to DO, and they are radii. Okay, I've joined it already. Okay, so when we do that, we are going to realize that this is the center of that circle, and then by implication we are going to have it that this angle AOD is equals to 2 times ABD. 2 times AOD is equals to 2 times ABD. This angle here. Do we get that? How? It is just what we proved in the last class, that angle which a chord subtends at the center of the circle is twice the angle which is subtends at any other point on the circumference of the circle. So this angle here is 2 times this. So we will back it up by that theorem, that angle at the center is twice angle at the circumference. Okay, we will back it up that way. That means what we are saying is that AOD is equals to 2x, 2 times x. We will also see that this same AOD at the center is also equals to 2 times ACD. 2 times that angle. Okay, we also back it up by the theorem we have already used here, that angle at center is twice angle at the circumference. Okay, we also back it up, and then it then means that AOD is equals to 2y. So if I call this one star 1, Then I will call this one star 2. Then I will say comparing star 1 and star 2. You realize that AOD is common in them. You say that AOD, this angle AOD is equals to 2x, which is also equals to 2y. It's common in them. So it then means that therefore 2x is equals to 2y. By implication, then it then means that it implies that x is equals to y. And what is x? X is A, B, D equals to what is y? And that is A, C, D, as we were able to, show here. Okay, we started with that and we're able to conclude with that. All right, this is in few steps the way to show that angle which a chord angles in the same segments are equal. And we were able to explain that using the first theorem that says angle which a chord subtends at the center of the circle is twice angle which is subtends at any other point on the circumference of the circle. So I am trusting God that this brief and simple explanation is good enough to help you to understand what this is all about. Please, after these theorems, we are going to be bringing problems where we are going to be making use of this theorem in solving practical examples and questions. Please, you have to stay with us. Like our video and share it to your friends out there, and then click also on the notification button so that you'll be notified as we make our uploads. Thank you so much for being there.